Hello, my name is ASAv HA and I'm Technical Marketing Engineer working for Security Business Group. In this video, I will talk about Cisco ASAv HA solution for Azure. In public cloud today, there is no layer 2 visibility, and in the absence of layer 2 visibility, it is very difficult for us to create a native HA solution. In order to design end-to-end solution, we leverage a couple of native tools using which we are able to achieve end-to-end HA in Azure. Let's talk about components which we use in order to achieve HA. First component is UDR. UDR is native component of Azure, and it stands for user-defined routes. Using this routing protocol or route table, we forward traffic to active ASA. Another key component that we use is LB or Azure Load Balancer. Using this component, we forward inbound traffic towards the active ASA. Let me draw my Azure environment and I will talk about end-to-end traffic flow and complete design of HA in Azure. This is a VNet. In this VNet, I have external facing load balancer. On this load balancer, I have public IPs. Internet users will hit this public IP address to reach my backend servers. Behind this load balancer, I have a pair of ASAs running in HA. This is our new marketplace offering. When you will deploy this HA pair, you will get two ASAs by default. So we get ASA 1 and ASA 2. This is active standby deployment. Both ASAs are added in the load balancing pool. One of the ASA is active and the other ASA is standby. By default, when you deploy these, you will get HA agent installed on the ASA. There are three important responsibilities of HA agent. I will talk about that in a couple of seconds. Behind our ASA, we have our internal subnet. We can call it inside or protected subnet. In this subnet, we have workloads. And these workloads are protected by a pair of ASAs running in HA. We have UDR. So current traffic flow is traffic from workloads will hit UDR. UDR will look at the route table and forward it to one of the ASAs available in the pool. And that way it will go to internet. Now, let me create a dotted line for my secondary path. So this is our secondary path, which is marked as a dotted line. Now let's talk about responsibility of HA agent. First responsibility of HA agent is to keep track of both units. Which unit is active, which unit is standby. HA agent will keep track of that. Another important duty is to respond to probes coming from load balancer. Only active ASA participates in responding to probes from load balancer. And the other HA agent will not reply to probes. Reason is we want only one ASA to be visible as healthy device in the load balancing pool. If both devices are healthy, load balancer will do the load balancing of the traffic and will forward traffic to both devices. But this is active standby solution, so we want only one device to look as a healthy device on load balancer. The other important responsibility of HA agent is to send REST API call in the event of failure and change route in UDR. So this is most important duty of this load balancer. So assume there is some problem with ASA 1. The moment this ASA is down, this HA agent will initiate a REST API call and initiate a route change. Also, the moment this ASA, second ASA will become active, it will start responding to probes. The moment these probes are received on the load balancer and there is no reply from probes from this side, so this connection will be completely removed and users from inside will take this route to reach internet. Important things to remember here, these two ASAs are separate ASAs and there is no configuration sync, and you need to manage these devices individually. So this is how our ASA solution is designed, and I hope you enjoyed this video. Thank you for watching.